So we have the inlet distributor, we just talked about it. It could be half pipe, dished plate, or cyclonic device, weighing pack. These are the inlet distributors we can use for different applications. So if you need, for example, very efficient one, for the inlet distributor, you can use cyclonic pack or weighing pack. We reduce turbulency. The demisting device. Demisting devices are used mainly here for the gas outlet. For what? Connect from gas. Next one, oil overflow weir. Why do we need that?
To separate the liquids.
Liquid from liquid. Which liquid, for example, Sana?
Oil from water.
Exactly. So the weir, for example, the overflow or submerged type you may have, overflow or submerged. Submerged is from the name, it's submerged into the liquid, but the overflow is like a kind of weir. It's in the gray color, this one. So as we have, let's say the lighter phase on top, it will go beyond this part and the oil. And the water, the heavier one, will stay here. So let's write liquid separation. Next one, the vortex breaker. Who knows about the vortex breaker?
Can I say?
Yes, let's say.
For example, we have the flow, and also you know that even the flow, we have very valuable things like components.
Yes.
And vortex means in Azerbaijan burulgan, and when the burulgan, when the vortex occurs, the our fluid like goes through the out.
Which fluid? Which phase?
Which phase?
Yes.
Water phase.
Water or oil?
Yes.
Okay.
And we want to go to the out the very important space, like we want to go out there, for example, methane or other very specious material.
Which material?
Like important.
Which phase is this important material? Important, let's say,
Water,
products? No. You have the water, you have the oil. It has two purposes, as you mentioned. So we have kind of the, let's say, if we have very not smooth, very rapid kind of the outlet discharging, let's say, from water and oil, right? We have the vortex created here, the whirling effect, burulgan effect. So the vortex created. In order not to mix the water and oil together, or water and gas molecules also. We have gas and let's say the water or gas and oil, or water and oil or water. Therefore, we have the kind of, let's say, the spiral. It's in the X, kind of looks like the X. So it tries to not to have the whirling effect and make it more smooth, and it breaks the vortex. That's why it's called vortex breaker. Okay. So why we are using it, once again, we have the vortex created at the discharge of the liquid phases, water and oil, in order not to mix and also lose our, let's say, precious compounds, especially gas or oil in the water, or the vice versa. We are making like a rigid structure, the vortex, and it will be a little bit like a much smoother. The water will be only water, oil will be only oil. Okay? Clear? Any question? 3 or 4 years old already, and I had used this picture, and it also shows everything clearly. You have inlet device, you have the foam breaker just mentioned before, then you have the vapor outlet mesh pad, then you have the weir. We have also additional for the coalescing. Try to increase the efficiency of separation. Let's say just we talked about with Sanan with the droplet, right? This is, let's say, the water droplet, looks like this. Let's say this is 100 micron. Micron means 10 to the minus 6. 10 to the minus 6, okay? Its diameter, let's say, 100 micron, and the oil, let's say, it's 50 micron. It's just random values, okay? So we try to coalesce them. What does it mean? It tries to find, let's say it's the other part. The 50 micron will try to find the other 50 micron. 100 micron will try to find another 100 micron, okay? when they find each other, they are in love already. They are trying to get together like this and make it bigger, bigger and bigger. And this will be army of the 100 microns. And it will help at the end of the story to separate these two phases. Okay. The separator features inlet device to reduce the turbulence and velocity in the main separation section. How it was called? The reduced turbulence? No, inlet device to reduce. Inlet device. Inlet diverter distributor, yes. Mesh pad for entrained droplets. Mesh pad, why we are using mesh pad? Sufficient liquid residence time, it's another feature for the separator. So we need to have the sufficient residence time. Let's say this residence time should be 30 minutes, but we have got it like this 20 minutes. What happens? What do you think? It should be 30, but it's now 20. Meryem, what do you think? It should be 30 minutes, let's say. Okay, but now it's 20 minutes. In 20 minutes, this droplet, let's say, already going out from the separator. What happens to the droplet?
It still goes from the same process, but...
But what is different? Like from the, it's not 30, it's 20.
It just reduces the efficiency, that's why.
Exactly. So how do you understand efficiency to Zara now? Yes. What kind of problems we may consider in this, let's say, design? I said.
We will have some process errors.
Louder, please.
We will have some process errors that we...
Process errors.
Yes.
What kind of process errors?
For example, we will, if we want to have a pure substance, we will have some...
Mixed already. For example, oil with water, it can be mixed. Well done. I said. Exactly, guys. If you have the 30 minutes with design, but right now you get only the 20 minutes, it means that your droplets are still not separated from each other in the highest percent. You may have suddenly changed the rate of the flow rate. Let's say you have the amount of 20,000 kilogram per hour flow of, let's say, oil, crude oil, going into the separator, okay? But this is also the continuous process, and in the continuous process, you get the water here, and you get the oil from here, and the, let's say, the gas, right? So suddenly, there is something happened, and your 20,000 kilogram per hour, as we like already put as set point, it suddenly increased to, let's say, 50,000 or something, okay? So this flow rate, as we are changing, like increasing the flow rate, it will definitely affect your steadiness of the flow. Why do we need steadiness in the separation? Because imagine that you are trying to separate these droplets, or this is the first condition, or you are trying to separate this. Which one is easier? What do you think to separate? First one, because it's steady flow, it's steady state. But this one are not steady, and that's called unsteady state conditions, right? So the liquid surge means that when you're suddenly increasing the pressure or suddenly increasing the flow rate, your steadiness is changing. Therefore, liquid starts to be surge, increase, decrease, and it means that it definitely affects your separation. It goes like this. So therefore, to remove these things, we have the advanced control systems normally, but based on the practice, your control valve, your control system operates efficiently and removes all the liquid in the system and needs to help you with the separation. But if it doesn't work, there will be overflow case, as I mentioned. Okay. Now go back to this HLL, LLL. All of them has some meaning. So this is part of control system. LLL is the liquid level. This means low. It means that this is like the lowest design case that you could get in the separator. Low liquid level. Then we have low liquid level. normal liquid level. We try to always operate at normal liquid level, okay? Within some excursions within the high or low liquid level. But already reaching to, let's say, low or high liquid level, that's already like the worst case. For example, if I'm saying that this is an overfill scenario, it means that we have already reached the high, okay? And already this is gas part, right? The liquid is entering into the gas, and it affects our separation. This is the high, this is the low. But if you have the low case this time, just imagine that you have the low. You don't have the necessary amount of the liquid. Then what do you say? What could happen here? Saman?
Oil can get out from the water outlet.
What else? You have in this part you may have the more gas and low liquid. What happens?
Or pressure.
Sorry?
Gas particles can go through the...
Exactly. So if your liquid in the overfill scenario goes out from the gas, that's called liquid carryover. Just take this as notes. The liquid carryover. The vice versa. If from the liquid outlet we have the gas entrainment, that's called gas. No, gasblowby. That's called gasblowby. Okay. Most of the guys like kind of always confuse these words, but if gas from the gas outlet liquid is going, then it's called liquid carryover. But the vice versa case, we'll talk that from the liquid, if we have the gas, then it will be gas blowby. And when it happens, the gas blowby happens when you have the low liquid level, and liquid carryover happens high liquid level. Is it clear? Any question? At which point we are trying to operate? Normal. Well done. So at which point we call it overfill scenario? High liquid level, exactly. At which point we have the liquid carryover scenario? High liquid level. Okay. At which point we have the gas blowby scenario? Well done.